I'm going to show you guys a little piece of test equipment that I've had here for a little while. I just haven't shown it off before. In fact, I don't think I've ever even used this thing since I acquired it. I got to take it apart and kind of go through it first to make sure that it's safe to use. Of course, I'm talking about my Heathkit condenser checker. Now this has what they call a breakdown test capability. So what you can do is you can apply up to, I think it's 450 volts. Yeah, it'll apply up to 450 volts of power, DC, to check capacitors for leakage. And basically you can test resistors and you can test capacitors with this as well. And it'll check your power factor. I have to go through the manual and actually see how to use this thing because I've never used one of these things. But I figured it's a piece of test equipment. I had the opportunity to get it. I figured I'd better grab it while I could. Now, one thing I want to change on this, I want to get this AC cord and replace that because this AC cord is looking pretty ratty. So let's pull the back off this thing first and just see what's inside it. See whether I need to change any capacitors or anything in here. That's right, changing caps on a cap checker. I was going to use this when I serviced a vintage radio at some point. It just comes off like this. The whole unit pops out. So here's what's inside this unit. It's basically just two tubes. And one of them is the tuning eye tube. And in the bottom here, we've got a couple of big electrolytic caps, which probably wouldn't hurt to change them. Dry electrolytic cap, made in USA. So there's not much to it, right? This one here, 600 volts, 0.25 microfarads, probably should be replaced. Same with this one down here. These probably should be replaced on it. They may be okay, because something like this would not have seen a lot of use, but we can check the caps. This hasn't been plugged in forever, so there won't be any charge on them. We can check these and just see what the rating is, capacity-wise. So this one's going to measure 17.2 microfarads. And this other one is going to measure 15.1. What are they? Well, one's rated at 8 at 475 volts, and the other one is, what is this one rated at? See, these could be breaking down and going leaky. And this one is a, what is this one? This one is a 0.25. So we'll just check we'll check this one. Check the rating on this one. Showing 1 microfarad. This one's a 2 microfarad cap at 200 volts. This one's showing 11, but the gain, we could have leakage going through this control over here as well because it's going through this control. So that could affect those readings. But definitely I think these caps really should be replaced on this just because of the age of it. That's one of the reasons why I haven't used it. Is I got to get some high voltage caps. I'd like to change this power cord. This power cord kind of makes me nervous. I don't know, maybe it's okay. But I don't see any frayed insulation on it, so the power cord may be okay. But here's the unit itself. Another cap up top here, some resistors. It's got transformer, eye tube, and an amplifier tube. What is this? What tube is this one? This is a VT137, and that looks to be a triode. Is that a triode? Let's just see what how many grids we got on here. We got a cathode, we got a control screen, and a plate. So this is a triode. There needs to be only one screen on here. Yep, just one screen. So it's just this is a triode amplifier too, obviously. Throw the back cover on it for now. We'll fire it up and I'll try it out and see whether it does anything. So with this unit, you can measure resistors as well as capacitors. Got my resistance in ×1 modes. As you can see, here's our scale. However, this is measuring resistance. If I increase the dial, you'll see that you maximize the I tube, and that's your reading. And it's showing it's telling this is more around 20K. It's what this resistor is measuring. If I measure the resistor on my meter, we'll see what it really measures. Oops. Oh, this is a 20. Brown, gray, orange, 19, 20K. It's measuring 20K. And that's exactly what this is showing. This is showing that it's a 20K resistor. When I connect it up, I'm right at 20K. That's exact. The other resistor I've got here, this one is a 100 ohm resistor, which we can verify that it's 100 ohms. 117 ohms according to this. And when we put the resistor on here, it should be right down around here. And there it is. So it's measuring resistors okay. I wonder what kind of voltage this thing puts across these terminals. We can find out. We'll just connect it up here. Is it putting a voltage across here? Well, it's not putting anything in terms of DC, but it's putting 63 volts AC across. That's what it's putting across these terminals. Now, the same can't be true if I measure the capacitor side of things. If I move this over to the capacitor side, and we put this into DC voltage, shouldn't even measure this meter, but if I test my breakdown, I'm just going to see what voltage I'm going to be for. We'll set it for 25 volts for the leakage test. If I turn this to leakage, it's actually putting about 40 volts across here on the 25 volt breakdown. If I put it up to the 150 breakdown, 142 volts, 250, 235 volts, 350, 339 volts, and 450. This should be 426. So it's getting close. But that's the breakdown. So that's for testing capacitors for breakdown. I've got some old capacitors here. This only measures up to 1,000 microfarad. So I've got some old, like really old ones that were given to me here. I'm sure some of these are past their prime. Some of these are oil filled. Well, when you see a cap that's oil filled, you can pretty much rest assured that this has got some of those wonderful PCBs in them, because I mean this is going back to the 1960s or so, or whenever. So you can pretty much be guaranteed that they're going to be full of bad stuff. Here's an EDS cap, 1,000 microfarads, 10 volts. I can probably measure that on the 1,000 range here. If I clip this on, we'll see how it registers. It should, when I dial this up to 1,000, it should indicate that it is 1,000, which it is. You see the edges opening up, the eye opening up, and it gets nice and sharp. That's at the reading, and that looks to be, I guess, 1,000 scale there, 20 to 1,000. Yeah. Now this is a a 10 volt cap. So I would imagine if I put this in a 25 volt breakdown, it's probably going to fail. Let's just see what happens. Well, it hasn't failed yet. When they're bad, this closes right up. If you have a bad cap, like I have a bad one here that I can put on just for demonstration purposes. I can put this dead cap, which we know is leaky as anything, and it's all bulging. When I do the leakage test on here, watch what happens. Let's see some other small ones here. See if I can find some that are no good. This is a it's a 0.01 600 working volt. This is a good one for testing. So we'll put this cap on. It's a 0.01, so that'll be down in this range down here. We should see this show up. And there it is. It's a 0.01. And there it is showing me that it is measuring a 0.001, sorry. And I'm on the 0.001 to 0.5 scale, and right there I'm at 0.001. You can see it. And it's indicating that this capacitor is good. You see? It maximizes it right there, and that's pointing at 0.001. This cap is rated at 600 volts. So I can crank this thing all the way to 450, and we will see if this cap is any good or not. Watch the eye meter. It should close up, and then it should pop back open. And it did, just momentarily, see? And then it opened right up because this cap is not leaky. If the capacitor had been leaking, which I can demonstrate because there's a resistor here, and when caps go leaky, they basically turn into resistors. So we'll just clip it on the resistor there so you can see what happens. That is what happens when you have a capacitor that's breaking down under load. If I were to put a cap on that is rated at a lower voltage and give it a bunch of juice, I'm sure that it will probably, well, here's what, this is an old 220, old electrolytic, 10 volt. This thing's probably no good. Let's just try this one. So we'll take this down to the 1 to 50 scale. Connect this up, positive and negative. And this is a 220 microfarad, as I see. Yeah, 220. So we'll go to that scale, and that should come up around here when I dial this up. And it's not. It's coming up around 70. This one here has a breakdown voltage of 10 volts, so if I put this in 25 volts, will it pass or will it fail? It's not leaking at 25 volts. What if I put it to 150? Yeah, now it's showing some leakage. This one's an old 0.33 microfarad, rated at 250 volts. Perfect! Another old cap that we can test and see what's going on with this one. 0.33 will be down here on the 0.001 to 0.5 scale. So let's just see whether our capacitor is measuring what it should be. So it should be right around in here as we dial it up, and it's not even registering. Or is that 33 microfarads? It says 0,33. Maybe it's 33 microfarads. Oh, it's not registering anything. It's probably open completely. But it is a cap that's rated at 250 volts, so let's just do a breakdown on this and see what happens when we hit the breakdown voltage. Oh, it's not breaking down. It's opening up. But capacity-wise, should be 0.33. I should see it on here, and it's not showing up. Oh, there. Wait a minute. Wait a minute. That might be right there. I see a little bit of a deflection. Certainly not much showing up, but there is a bit of a deflection there. Well, that's got to be it right there. You can just see an ever so slight deflection. Fluke meter, 0.389 is what it's showing. I think there's another one in here. Let's just check this one out and see if it's the same. It's also rated at a 0.33. 0.430 is what that was showing. I get a little bit of a deflection at 0.1. Actually, here we go. On the other scale, here we go. On this scale, this is the 1 to 50. So I'm getting a little, just over 0.1, between 0.1 and 0.2 on here. And the 250 working volt again, if I go to breakdown, it's testing good. Go to 350, still testing good. About 450, still testing good. You know, it hasn't failed yet. Got another 0.33, 10%. It's actually measuring correct on the Fluke. This one being a more like a paper cap. What are we getting here on the meter? Should be right near the top of the scale. Actually, here this is 0.5. I should be somewhere right in here. And there looks to be a slight bit of deflection right there. You can just barely see it moving, but that looks to be reading, and that's out on this scale here. Here we go. Increase our power factor a bit for paper and mica as opposed to electrolytic. 0.3 would be right here, and this is coming up showing a 1.1, so it's not that accurate unless I'm reading this scale wrong, which is entirely possible. This one's rated at 200 volts, so if we put it to the 150, it should pass with flying colors, which it does. How about 250? How about 350? Still no breakdown. How about 450? Oh, did we start to fail a bit there? Nope. Let's have some fun. Let's charge this 1.1 microfarad capacitor to full power and disconnect it. There. Now this cap is charged, and if I put my meter across here, it should be holding a charge for a few seconds. That's the meter, by the way, that's discharging it. It's only at 0.1, so it won't hold a charge very long, but It did hold a charge there for a little bit. Here's another one. This is a 0.22. Let's just check the capacitance on this one too and see whether it was how it's looking. 0.1. Whoops. Yeah, 0.1. So this one's okay. This one here is a 0.022. It's right on. Anyway, I'm going to finish this up. We've been playing around with this thing too long. I'll do a service on this. I'll go get some caps and we'll change out the caps on this and see whether I get any different type of results on it. 0.22. So this should be a that should be that scale for a 0.22. It's not showing anything. In that range it is. See, looking at the scale here, it'll do, in one range it'll do 0.001 to 0.5, but the next range is 1 microfarad to 50. So what happens if you're between 0.5 and a 1? I guess you test it on this scale here because that would be 1 there. So I guess when we're going down, this is a 0.22. It certainly is measuring right down here at the bottom of the scale. But when I go to the next one up, or next one down, I would expect it to be 0.22. It should be right in around here. And I don't see anything. Interesting. This is a 400 volt breakdown, so we'll crank this up to 450. We'll see how this one, whether this one's going to fail. Nope. It's looking good. No problem. So even these ancient caps, I don't have any leakage on them. I was hoping that some of them would show some leakage. I'll use this when I service a tube radio, the next tube radio. But I want to recap this thing first. I'll put new caps in here, and that'll get this back in peak condition because, again, being it's old and it's got a bunch of paper caps in it already, I don't trust them. So we'll do a service on this. That's my little capacitor checker, little Heathkit condenser checker that I picked up that I have never used, and someday it will get used. But I'm going to restore it first. Thanks for watching.